Now that we are inside of Visual Studio Code, we can now create some examples of how the different reactive primitives work. So the first reactive primitive we're going to work with in Signals is called the writable signals. If you can recall, the writable signals has two default methods available, which are set method and the update method. So what we intend to do is to make use of the first method, which is called the set method, to toggle the view on the HTML templates. How do we intend to do this? The first thing we need to do is to create a variable called set data, and we're going to assign it to a signal, and the initial state is going to be false. As you can see above, we have signal already imported. That's why we are not getting any form of errors. Next up, we're going to create a function called hide and show. Within this method, we're going to create a if condition that says if this dot set data is equals to false, then we open a bracket. We can now say this dot set data as true. We can now say this dot set data dot. As you can see, these are the different methods available for us in the set data signal. We have updates, we have sets. So we need to make use of sets. I'm going to set the value to true when this dot set data is equals to false. This helps us to create a form of toggle, and then else we set it back to false. So we can just grab this dot set data dot set and pass in false. We're going to save what we've done so far, get straight to the HTML file, and within the HTML file, we can create a div, and then we're going to create an ngIf condition that says ngIf set data, which is of course a signal. And within this div, we're going to create a text called hello, and then we need to create a button. So I'm going to create a button, and within this button, I'm going to type in show and hide, and then we pass in the function using the click event handler in Angular, and then we need to call the function we created in our TypeScript file, paste it in here, and then we can now save everything we've done so far. So to test it out, we know the initial value is false, so nothing is showing on the page. So if I toggle the button, you can see we get to see hello. If I click on the button again, it sets it to false. So with the set method, we're able to create a toggler that helps us to either show a particular text or hide the text depending on the state of the signal. Next up, I would like to look into the update method in the writable signal. For the update method, we're going to create a new variable called count. So I'm just going to type in count, and then I'm going to initialize a signal, and it's going to take in a value of 1. Remember, signals are able to take in generic type, so I can just pass in a number here to signify the variable I defined as the initial value for our signal. So if I scroll to the bottom, I can then create a new method called update, and within this method or function, I can say this dot count dot update, then we open a bracket and define a parenthesis with a value of w, pass in a path arrow, and then pass in w multiplied by the number of 2. What we are trying to do is to create a button that multiplies the initial value by 2 every time the button is clicked. So to complete the implementation for this, we head straight to the HTML file. Within the HTML file, we create a div, and within this div, we create a p tag, create a string interpolation, and then initialize our signal, which takes in a parenthesis. Finally, we create a button called counter, and then pass in the function as a click event handler. To be sure we have the right function, I'm going to copy this update, paste it in the click event handler, and then save everything we've done so far. As you can see, the initial value of the count variable is 1. Once I click on the counter button, it gets multiplied by 2. So every time we click the button, the number gets multiplied by the value of 2. with this, we're able to exemplify the explanation we gave earlier, which says the update method receives and updates the previous value of the signal. This is exactly what is happening in this scenario. Next up, let's look at the compute reactive primitive. For the compute, we're going to define an array. So I'm going to scroll up to the page, create a new signal called data, and then type in random numbers for the array. So let's do that now. What we want to do is to make use of the reduce method in JavaScript to add up all the numbers in this array. But to help us with that, we need to make use of computed. So quickly down below, we can just create a public variable called total. And with that, we can now initiate computed. With computed, we can now create a parenthesis, create a fat arrow, and then we can now say this dot data dot reduce, and then initialize a function which takes in two arguments. The first one is the accumulator as well as the value. Then we open a bracket, and within that bracket we return the accumulator and then add it to the value, and then we add an extra argument with a sum of 0. Since we have an error that says reduce does not exist on type writable signal. Okay, I think we forgot to initialize our parenthesis, which I'm going to do right now, and with that error gets cleared. And then we can now save what we've done so far, head to our HTML templates and try to display the signal within a p tag. So all we need to do is just to call the total signal and then save to see if it gets displayed. As you can see, with the help of the computed, we're able to sum up all the values within the array, which adds up to 257. With that, we're able to exemplify the power of computed. Finally, for the reactive primitives in Signal, we need to do something on effects. Before we proceed, we need to know that effects can only be defined inside of an injection context. What do I mean by this? If we define effects outside of an injection context, we are going to get an error, just like we have right here. You can see the error which says effects which lacks return type annotation implicitly as an any return type. Also, if we copy and paste this effect inside an ng on init lifecycle hook, we'll still get an error. So one of the major places the effect can work is within the injection context. So what we want to do next, which is the final example in this lesson, is to create and display a chart. I already have the chart.js library installed for this project. I'm going to create a variable called charts and then pass in a type of any with an initial array which is empty. So I'm going to paste in a sample of the chart.js library which I got from the chart.js documentation within the effects. As you can see, we called an instance of the charts variable we defined above by saying this just chart, and then we initialize our charts, which you can see right here, which has a bunch of default values from January to July, as well as data, which shows the value of the data within this array. So for now, we can see that the months, which are 7, does not equate to the number of value of arrays we have. So I'm going to increase the number of values we have to 7. So with this, the data and the value of the labels we have are of the same number of length. So to display this chart in the browser, I need to comment everything we've done so far and then create a div. And within this div, we can initiate the canvas, which needs to have the ID of canvas. And then we can call the chart variable within the string interpolation. As you can see, the chart displays successfully on the browser. With that, we've been able to display one of the functions effect is meant to serve as a reactive primitive in Signals.
If you want to keep learning about how to build real-world apps with the latest technologies and other career-related topics, then start right now by subscribing to our channel and liking this video.